Assalamualaikum warahmatullahi wabarakatuh. Our group for today will be presenting the application of differentiation, which is the applied maximum and minimum. I will be introducing you to our group members. My name is AMIR HAFIZI bin MUSA, and the other two group members is Muhammad AZRUL AIMAN bin Abdul Rashid and Muhammad DANIAL HAKIM bin Muhammad ISMAIL. The tables of content that we have are: one, introduction to applied maximum and minimum. Second one is what is applied maximum and minimum. Third one is why we use applied maximum and minimum. The fourth one is how to use applied maximum and minimum. The fifth one is the problem statement that we have. The sixth one is the conclusion. And the last one is reference. Now, we're going to be going to the first one, and let us begin the journey. Introduction to applied maximum and minimum. Finding the maximum or minimum values for various functions is a common component of calculus application problems. The domain from which you are must operate depends on the limitations that are explicitly or implicitly imposed on such service. In order to determine a maximum or minimum value, the function and its domain will provide suggestion for the best method to apply.
So, what is maximum and minimum? Definition and meaning of maximum and minimum is the maximum point of a function is the highest point on the function's graph. This location on the graph also has the highest y value of any other point. The minimum point of a function is where the function's graph is at its lowest point. This location on the graph also has the lowest y value of any other point. Optimization is the process of figuring out the highest or the lowest possible value. And then why we use maximum and minimum. Reason to use them, for instance, in order for the glass window we want to install in our room to fit within the window frame, we must calculate the pane's maximum surface area. We employ applied maximum and minimum in order to overcome problem of this kind.
Number 4. How to use apply maximum and minimum. This is quite how to use it. Firstly, you need to create a diagram of the issue and label the importance number on it in order to begin understanding the issue. Second, find the equation that describes the quantities whose maximum or minimum value has to be calculated. Step required to find the derivative. First, let the derivative equal to 0 and find the value of the variable. Do the second derivative test. If the second derivative test value is more than 0, that is minimum value. And if the second derivative test value is less than 0, that is maximum value. This is example of formula on how we use and apply maximum and minimum. Number 5. Problem statement. Figure below shows a right cylinder closed at both ends has a radius x and height y. Question A. If the surface area of the cylinder is 150 cm square, write y in terms of x. Question B. Prove that the volume of the cylinder is volume equal to 75 pi x minus pi to the power of 3. And C. Find the value of x such that the volume of the cylinder is maximum. Firstly, to solve question A, first step we must know and write cylinder area formula, which is 2 pi x squared plus 2 pi xy. And then equal the formula with the cylinder area that already given by the equation, which is 150 pi. And then move 2 pi x squared to the right because we want to find y in terms of x. Next, move 2 pi x to the right, and it will become 150 pi minus 2 pi x squared divided 2 pi x. Next step is to separate if we want to simplify it easily. After we simplify it, it will become 75 over x minus x squared over x. And lastly, write the real answer, which is 75 minus x squared over x. For question B, first step, we must know and write the cylinder volume formula, which is pi x squared y. Next step is to replace the y that we already got from question A into the formula, and it will become volume equal to pi x squared times 75 minus x squared over x, and then multiply pi x squared by 75 and multiply pi x squared by minus x squared and then over it with x. It will become volume equal to 75 pi x squared minus pi x to the power of 4 over x. And last step is to simplify the equation by cutting oscillating x, and then it will become volume equal to 75 pi x minus pi x cubed, which is the same as the equation 1 that we want to prove. For question C, write again the volume formula that we already got from question B, which is volume equal to 75 pi x minus pi x cubed. Next step is to differentiate the equation, and after that, it will become dv over dx equal to 75 pi minus 3 pi x squared. And then, write dv over dx equal to 0. After that, dv over dx, which is 75 pi minus 3 pi x squared, will equal to 0. Solve it by moving 3 pi x squared to the right, and it will become 3 pi x squared equal to 75 pi. Next step, move 3 pi to the right, and it will become 75 pi over 3 pi because we only want x on the left side. After that, calculate 75 pi over 3 pi using calculator. And then the answer is 25. Next, to get the value of x, we need to square root of 25, and it will become x equal to 5 cm. To prove it is maximum, we must do the second derivative for the volume equation. After differentiate it for the second time, it will become negative 6 pi x. And then, when x is equal to 5, replace 5 into the negative 6 pi x. And it will become negative 6 pi multiplied by 5. And then calculate it using calculator, and the answer is negative 94.25, which is it is less than 0 because the value of x is less than 0. So x, which is 5 cm, is the maximum value.
And moving on to the conclusion, summarizing what we have learned today, overall, in order to obtain the value for question A, we must first understand the cylinder area formula. Then for question B, we must know the cylinder volume formula so we can replace the y value that we calculated earlier with the volume formula. Finally, to answer the question C, we must calculate the derivative, set it to 0, and then calculate the value of x. Additionally, a second derivative test must be run to determine whether the value is maximum or not. If the second derivative is greater than 0, then the value is maximum. And moving on to the reference that we have, that we got from the sources of reference, reference 1, reference 2, and the last one. And by that, that is the end of our presentation, and thank you for listening.